Hi guys, I'm Debbie and this is LM Square S, and if this is your first time watching my video, please make sure you like and subscribe. Without wasting much of our time, we have something very important to do here today. We are treating the topic calculus. What is calculus? Calculus is the study of differentiation and integration. It simply explains the changes in values related to any function. Calculus is therefore broadly divided or classified into two. We have differential calculus and we have integral calculus, okay? But today we'll be talking about differential calculus. Differential calculus deals with the problems of finding the rate of change of a function with respect to the other variable. Please take note of this. With respect to the other variable, we have these variables. We have the x, we have y, we have the f of x, and we have two symbols also. We have dy and we have dx. We call these differentials. And so the process of we finding the derivatives is what we call differentiation. So differentiation now is a change in variables with respect to another variable. So let's take, for instance, we're given the parameter y expressed as a function of x. So what we have now is y equals fx. So to differentiate or to find the change in one variable with respect to another variable, don't forget that was what I called differentiation. So let's find the change in y with respect to x. We'll be having dy over dx equals f prime x or fx. I hope you get this. So this is just simply the concept of differentiation. So I have 6 methods here in which we can use to solve differentiation. So the first method I have here, I have the general method, I have the first principle method, I have the chain rule or function of a function or functions. I have the product rule, I have the quotient rule, and I have the implicit differentiation. But today we'll be dealing with the general method. So let's see how general method can help us in differentiating. Let us see how we can solve differentiation using the general method. Okay, let's assume we are given a function y. Let's assume we're given a function y here. Y is expressed as a function of x. Is expressed as a function of x, and it is giving us x raised to power n. Now, so y equals to x raised to power n. Don't forget here, the x here is the base. X is the base, while n here is the power or index. It's the power or index. So now, if we're to differentiate using the general method, there's an ideology I want us to know. So the first thing is to multiply first by the power. This is the power, which is n. Multiply by the power, then subtract 1 from the power. Subtract 1 from the power. So let's differentiate now. We'll be having dy over dx equals n, which is the power, times x raised to power n, which is also the power, minus 1. As simple as that. So, okay, let's simplify. N times x raised to power n minus 1 will be giving us nx raised to power n minus 1. As simple as that. So let's go. We have some examples here. I have 2 examples for us here. So let's look at the first one. Differentiate this. Y equals x raised to power 5. Y equals x raised to power 5. So let's solve this. The first thing I want you to know is always make sure you rewrite the expression. Just make sure you do this. Let's rewrite the expression. We are having y equals x raised to power 5. So let us differentiate. Don't forget, I told us the ideology here. Multiply first by the power, then subtract 1 from the power. Multiply first by the power, then subtract 1 from the power. So we'll be having dy over dx, dy over dx equals, the power is 5, 5 times x raised to power 5 minus 1. Don't forget, we're subtracting 1 from the power. Okay, 5 times x raised to power 5 minus 1, giving us 5x raised to power 4. How did I get my 4 here? 5 minus 1 is simply giving me 4. So I have 5x raised to power 4. So let us take a good look at the second example we have here. Let us look at this. This might be looking very complex, but don't worry, we're going to break it down. Y equals x raised to power 4 minus 2x raised to power 3 plus 2x raised to power 2 minus 8x plus 15. You might be looking at this as different. This is a constant. This is a constant. Why is it a constant? It is carrying no variable. If you take a good look at the rest here, they are having x, x, x. Well, this is not having any x. It is carrying no variable. So this is a constant. Okay, let us differentiate. Now, dy over dx equals, now, I hope you can remember the ideology. Multiply first by the power, then subtract 1 from the power. Okay, the power here is 4. 4 times x raised to power 4 minus 1 minus 3 times 2x raised to power 3 minus 1 plus 2 which is the power here, 2 times 2x raised to the power 2 minus 1 minus 1. How did I get my 1 here? Don't forget 8x is also, there's a 1 here. So 8x raised to the power 1 is also the same thing as 8x. So 1 is the power here. 1 is the power here. 1 times 8x raised to the power, that same 1 minus 1. I hope I'm getting this. Now plus 0 times 15. You might be wondering how I got my 0 here. If you take a good look at my notes here, I said differentiating a constant gives 0. So whenever we are differentiating a constant, it gives us 0. I might not have the time to, prove this to us, but probably in our next lesson, I'm going to explain how we can differentiate a constant and how it is giving us 0. I hope you get this. Okay, so dy over dx equals 4x raised to the power 3. How did I get my 3 here? 4 minus 1 is giving me 3 minus 2x raised to the power 2. 2x raised to the power 2. I hope you understand how I got my 2 here. 3 minus 1 is giving me 2. 3 times 2x raised to the power 2 is giving me 6x raised to the power 2 plus 4x. Now 2 minus 1 is giving me 1. 2 minus 1 is giving me 1. 2x raised to the power 1 is the same thing as 2x. Now 2x times 2 is giving me 4x. Okay, minus 8. How did I get my 8 here? 1 minus 1 is giving me 0. And don't forget the power rule in indices. Anything raised to the power 0 is 1. X raised to the power 0 is giving me 1. So 8 times 1 is giving me 8. Minus 1 times 8 is giving me 8. It's giving me 8. So we have minus 8 for the solution of this. Okay, minus 8. So I can simplify further by factorizing. Yeah, we have a common factor here. We have a common factor here, 2. So 2 into 2x raised to the power 3. I hope you understand I got that. Divide this by 2, divide this by 2, divide this by 2, divide this by 2. So we'll be having 2 into 2x raised to the power 3 minus 3x raised to the power 2 plus 2x minus 4 minus 4. So let me remind us of the ideology for general method. Multiply first by the power, then subtract 1 from the power. And also take note that whenever you're differentiating a constant, it gives us 0. Okay, I hope we got this. I hope we got this. So the exercise for today, differentiate this. Fx equals x raised to the power 11, then differentiate 6x raised to the power 3 minus 9x plus 4. Okay, so I hope we were clear with this, or I hope we are clear with general method, and I hope we can see how general method can be used in differentiation. Okay, so if you have watched this and you have not subscribed to my channel, make sure you do so, like, and also comment. Thank you so much, and I love you.